In this lecture, we will discuss about two-dimensional arrays. A two-dimensional m cross n array A is a collection of m dot n data elements such that each element is specified by a pair of integers such as j and k called subscripts with property that j is greater than equal to 1 and less than equal to m and k is greater than equal to 1 and less than equal to n. So basically two-dimensional array is a matrix form where m cross n, m represents the total number of rows and n represents the total number of columns in a matrix. The total number of elements is the product of m dot n. So we can represent a two-dimensional array in the form of matrix with the constraint that the subscripts that are specified by j and k, the value of j will range from 1 to m. Means the total number of rows present in our array is from 1 to m, where m is the total number of rows present in the array and the total number of columns will vary from 1 to n, where n is the total number of columns in an array. The element of A with first subscript j and second subscript k will be denoted by these notation. Either we can represent by a and them by a, j, comma k, or in parenthesis forms. Sorry, in bracket forms. So this is the representation of the two-dimensional array. Here the horizontal ones are called rows. Horizontal line is called rows and the vertical line is called column. Here first subscript indicates the row and the second subscript indicates the column. So if we see this, here you will see that first subscript is changing and the second subscript is same. Means we are talking about the zeroth column, zeroth row, zeroth column, first row, zeroth column, second row and zeroth column. Same is with others. So the rows, the horizontal lines are the rows and the vertical lines are the columns. So let A be a two-dimensional array with m cross n, means m rows and n columns. So we represent m cross n elements of an array in sequential memory location. So there are two ways in which we can store the elements of an array in memory: column by column and row by row. So column by column is also called column measure order. So by default Fortran language and MATLAB language store the elements of the two-dimensional array in column measure form, and row by row also called row measure order, in which the languages C, C++, Java, these programming languages store the elements in row measure form by default. Means what do you mean by column measure form? Means first the elements of the elements of the array are stored in sequential memory location. So first in column measure form, first the elements of the first column will get stored, then after the elements of the second column will get stored, then after the elements of the third column will get stored. Same case with the row measure order. In this, first the elements of the first row will get stored, then the elements of the second row will get stored, and then the elements of the third row will get stored. So here if you want to see the difference, if this is the memory locations in the computer, here you'll see that first if we talk about the column measure order, here you are seeing that the column is same and the row is changing. In first location, we store the first element at the first element in first row and first column, then the second element in second row and first column, then the third element in third row and first column. This is the first column. Then we store the elements of the second column, then we store the elements of the third column, then we store the elements of the fourth column. Here rows are changing but columns are same. If we talk about the row measure form, we first store the elements of the first row. If you see the subscripts, here the row subscript is same and column subscript is changing. Means first we store the element of first row, first column, then first row, second column, then first row and third column, then first row and fourth column. So we keep changing the columns, but the row is same. So in row measure form, we first store the elements of the first row, then second row, and then the third row. So in the previous lecture we talk about the single dimensional array. So if we want to track the location of the kth if we want to track the location of the element at kth index, the formula was base address of LA plus W, where W is the size of the element, kth index minus lower bound. So but in a column, but if you want to find out the location in two-dimensional array, there are two major forms. If the elements are stored in column measure order, or the elements are stored in row measure order. So if the elements are stored in column measure order, the formula is, if you want to find out the location of the element at jth row and kth column, then first you have to find, know the address, base address of the array, plus W, the size of each element in the array, M, the total number of rows present in the array, K, the column at which you find out the address of the element, minus lower bound, plus the row at which you find out the address of the element, minus lower bound. Same case with row measure order. So here we are changing. If we are talking about the column measure form, we are multiplying it with the total number of rows, and if you are talking about the row measure, we are multiplying it with the total number of columns. And here n is the total number of columns in the array, j is the index of the row at which you find out the address, minus lower bound, plus k is the index of the column at which you find out the address of the element. So in row measure order, AJK is base of A plus W, the total data type, the size of the data type of each element, the n is the total number of columns, J minus LB plus K minus LB. Same case is with the column measure form. So let's take an example. Let's understand it with the help of example. If we have an array of 25 cross 25 cross 4. So the total number of elements present in the array according to is 100. So here we have 25 rows and 4 columns. Suppose the base address we have taken 200 and the data and the size of the data type is 2. So if you want to find out the location of the element present at 12th row and 3rd column, so and if the elements are stored in row measure form, the formula is this. And if I want to calculate the address, then base address is 200 plus 2 is the data size of the data type, total number of columns here is 4, j, here what j is indicating, 12, 12 minus 1, here we have start the index from 1, plus k, the value of k is 3, 3 minus 1. So after manipulating, the answer is 292. So in this way we can calculate the address of an element if we know the base address, the size of the data type, and the total number and the size of an array. Thank you.